Hi there, Classpad.net users. Today I'm going to focus on exterior angle sum and some visual ways you can help students come to an understanding of the exterior angle sum and then verify it with measurement. So first thing I'm going to do is actually construct some polygons. So if you were doing this with students, my recommendation would be, I'm just going to open 2 geometry stickies, but you'd have each student open a geometry sticky and they would construct their own polygon, whether it's a triangle, a quadrilateral, a pentagon, a hexagon, etc. It would be good to get different examples of the same polygon and also different polygons, right? So let's say a student, and I would suggest you're trying to get the exterior angles, so you want to use rays for their constructions so that they see both the interior and exterior. So a ray, so let's just do a triangle here. A ray, if you notice, allows you to see both the interior angles and that supplementary and exterior angle, right? So let's do another one over here in this other sticky. Let's just make a different one. Oops. I want to get my ray tool again, and this time, I don't know, let's do a pentagon. All right, so I've made a pentagon. It's not a very nice pentagon. There we go. Make it stick out. So again, rays help you see both the exterior and the interior angle. So at this point, when they're getting to the exterior angle sum, they've usually already done the interior angle sum. So now we're talking about the exterior angle sum. So let's actually visually see those exterior angles. So I'm going to go into use my arrow, and I'm going to actually measure just so I can visually see. And because it's not the interior angle, it is the supplementary or exterior, that's the one I'm going to measure here. So let's do all of our exterior angles here. So this just gives me a nice visual of the actual exterior angle. It does have a measure, but I'm not adding it up. Remember, we're doing exterior angle sum. I'm not adding it up at this point, but they do visually see the angles, and that's going to help us come up with our conjecture. So let's do these same ones over here. So when I click into this other sticky, I'm going to do the same thing. I'm going to select and measure my supplementary angles so that I can start seeing where they are. This will make more sense as we actually go into our visual conjecture mode. So every student has done this. Let's say they've measured. They visually are showing all the exterior angles, so not the interior, so the supplementary. And now what you can tell the students to do is to click on their sticky, and whether they're on a touchpad like an iPad, a Chromebook, or whatever, or they're using a mouse as I am, you can zoom in once you're in the sticky. So I'm using my mouse scroll thing to zoom in. If you had the touch screen, you would use your fingers to zoom in, however that works. But I'm going to go into my shape. So every student has their shape. They've measured their exterior angles, or they're seeing their exterior angles, and watch what happens as I zoom. So what's this doing? It's making a dilation of my original. It's a smaller version of it. But notice as I do that, even when I zoom out, those exterior angles have not changed their measure. They're exactly the same, even though my triangle is physically getting smaller or bigger depending how I'm zooming. And as I get smaller and smaller, this is what we're trying to get them to see, those exterior angles are coming closer and closer together. And as they get really, really close, what does it look like they're making? And this is bringing up some prior knowledge. They're making a circle. All those angles are coming together at a single point. They didn't change the entire time that I was dilating, whether it was up larger or smaller, but they're coming together and they're making a circle. And what do students know about circles? They know that circles add up to 360. So just from this visualization is my exterior angles haven't changed, but as I bring that triangle or whatever polygon they're using smaller and smaller, those angles are coming closer and closer together. And when they join in that single point, they're making a circle. So the conjecture is if they make a circle, they must add up to 360 because that's what a circle measures to. So then I can, let's center this again, and I can change my shape. So this is something I would encourage too. Make it be a different triangle so that they see if it works for all the different polygons that they have. So again, I changed my triangle, and now I'm going to zoom again, but notice it's still making that circle no matter what triangle makes. So my conjecture seems to be holding true, that those exterior angles are adding up to 360. Well, let's try a different polygon. So remember, you'd have your students all with different polygons, several with triangles, several with quadrilaterals, several with pentagons. I mean, you might have some that have done, you know, a hectagon, you know, larger. But as they zoom, so all they're doing is clicking on the screen, and they're using their zoom feature, so either their mouse or their fingers, however they're zoomed, but they're going to slowly zoom in so that they can see the exterior angles never change size, so just different versions of that triangle. But as those angles get closer and closer together, they are coming together in a point and making a circle, therefore they must add up to 360. And you can click this button right here that just recenters and bring you back to your original. And then encourage them to change the size and the shape of their polygon and test it again and see if that 360 seems to hold true. So do that several times. Now they have this conjecture, well, it seems that those measures of those angles, of exterior angles, are adding up to 360. Let's verify that by actually measuring them. So notice you have your, I'm going to move my sticky so they kind of go with the sticky they represent. So notice here are my measures for each one. I've got the actual measures. So we're thinking that if I were to add them up, I should get 360 because they're making that circle. Now I can actually add them up. And so to do that, I'm going to go into measurement and go pull out an expression. And what that does is it brings me this sticky that I can now notice. Once I get expression, those measures, anything I've measured or calculated, has now got a plus sign near it, so I can actually use them in the expression. So this becomes dynamic. So if I click on that, and now we're just going to add the different angles together, and it's basically taking that measure and putting it in there. And when I hit execute, my conjecture was it should be 360, and it does look like it is. And then they can go back and see what happens. Well, let's change the angles. Let's see what happens to the sum. And notice my sum, even though my angles have clearly changed, is staying 360. So now I've got it verified. My conjecture that I visually saw is now verified with my measurements. Doesn't seem to matter what angle I change, how I change those angles, they're still adding up to 360. Right? And that matches my conjecture when I was moving them. So let's do the same thing over here. Let's actually go into measurement, get an expression, and add up these 5 angles, because this is my pentagon. So let's move it down where I can see it. All right, so what is my expression here? Well, this time I've got my 5. So first one, second one, third one, fourth one, and my 5th one. Now hit execute, and it again should be 360. That was our conjecture, and it does add to 360. So now again we can test and change the angles and see if we're still getting that 360, and we are, no matter how we change it. So we've done it visually, we've done it numerically, and you've got a nice exploration with different polygons, and it seems that no matter which polygon we're working on, the sum of the exterior angles is 360. So a nice visual and way to show and help students come up with the conjecture on their own, and then to verify it with the actual numbers.